Hello everyone. Thank you for being here to watch our presentation. I am Nidhi and here are my teammates Nikita, Shivanand, Jason and Saubhagya who have worked effortlessly to complete this project. We have worked on this project under the guidance of Kaushik sir. The title of our project is E-Decor, which means electronic decor. The meaning of decor is decor or decoration. We followed 5 steps of engineering design process to complete the project. The first step of engineering design process is carving out the problem definition, which essentially consists of objectives, constraints and functions. For our need statement, we have formulated the objectives, functions and constraints as shown in the problem definition. Objectives are shown in red color, constraints are shown in green color and functions are shown in blue color. So the problem definition states that we need to design a decorative device that is controlled by the user's commands. It should be portable and user-friendly and must be interactive with the user. It should work for a minimum time of 3 hours and the weight of the device must not exceed 1 kg. Device should be within a cost limit of 3000 rupees. The main features of the device are it should have an interactive musical system. The lighting pattern should be operable remotely. The pop-up blasting is wirelessly controlled, that is, via Bluetooth. Further, the functions are elaborated into sub-functions as shown in the tree diagram, and you can see the clustering also. The 3 functions that our decorative device must incorporate are remote lighting, musical instrument, and auto popper. Remote lighting works when we send an input data through SMS or call. The data is received and interpreted by the Arduino. After that, the light starts glowing with a particular pattern. Musical instruments. It reads the data through the photosensor or LDR, and after reading the data, it plays its corresponding tune based on the data sensor's input. Next, the working of popper is quite simple. When we send the data to the Arduino via Bluetooth, the popper pops up and blasts. In function clustering, we have clustered these function blocks in order to perform their respective functions. That is remote lighting, musical instruments and auto popper. Now let us find the subsystems that we have identified. They are remote lighting unit, musical system unit and automatic popping unit. So these are our subsystems.
Let us discuss the step 2, which is conceptual design. In this step, we are trying to generate various alternatives to realize the functions where we have come up with the 4 diverse solutions. These are our 4 generated concepts, and one of the concepts has to be selected from these 4 concepts for our final project. So, in order to select the concept, we made a pug chart that studied objectives such as ease of use, portability, safety, interactive, cost. On this basis, we analyze the 4 concepts to give up with the final one, and this is the final one which has got the highest ratings in the pub chart. And the next phase is product architecture, which includes virtual implementation. During this phase, we considered the identified subsystems and tried to identify different types of interactions in the form of data interactions, material interactions, energy interactions, and facial interactions. However, in our case, data and facial interactions are found. We started virtually visualizing it by developing a 3D model in the software Autodesk Inventor 2020 version. We studied the various subsystems and as shown in the figure. We have mainly 3 parts: the upper part and the middle part and the lower part. The upper part contains 7 laser modules which emits laser beam, which is received by the laser sensors that are fixed in the lower part. The rod supports the upper part and the lower part, and rod surrounded by serial light. And the lower part contains 7 laser modules inside it, and it is surrounded by 5 LEDs, which is equidistant from each other. And the LEDs and serial lights are controlled through remote lighting. And the next pipe-shaped part is popper. Popper part is controlled through Bluetooth module, and when the data is received, it pops out or blasts out.
Hello everyone, my name is Jason Xavier. As we all know, the heart and soul of every electronic device is the complex circuitry that exists inside it. It's the part that gives life to the electronic device. In our project, we have mainly three functions. The three functions is independent of each other. The first is the party popper, the second is the remote lighting, the third is the musical instrument. The party popper consists of a motor whose circuitry must be controlled from an Android device. To achieve this function, we use HC05 Bluetooth module to establish a connection between your Android device and Arduino. And to control the lighting pattern, this is the serial light that you can see here. To control it from anywhere in the world, and to achieve this function, we are using a GSM module which consists of a SIM. And if the user just call or send an SMS to the SIM, this entire circuitry, the lighting part, the lights change their pattern. And our project has a unique musical instrument with it known as the laser harp. It has 7 LDRs to play 7 corresponding classical notes of sargam, and it basically works like 7 LDRs have lasers that will be directly pointing towards it. So due to this lasers pointing at the LDR outputs a very high analog value to the Arduino. The moment we interfere between the LDR and the laser, the LDR outputs a low analog value which has been interpreted by the Arduino here, and it plays out the corresponding note. So this is basically a simple circuitry of our project. Now coming to the flowchart part. Every electronic device works on a certain logic. So even our project works under certain logic which we can explain with this flowchart. So every flowchart has these two blocks for sure, that is the start and stop terminal. So the first function, that is the GSM logic. So this is the statement. If the GSM is high, if this statement is true, the lights change their pattern, or else it remains in the previous pattern. So or else there will be no change in the pattern, the lights will continue its previous pattern. If it receives a signal like in the form of a call or a message, it will change the lighting pattern. Then coming to the party popper thing. If the data received by the Arduino via Bluetooth is true, if the Arduino receives data, if that is true, the motor activates. If not, the motor remains off. And now for the musical part. The musical part has 7 LDRs which will be continuously reading 7 analog values, that is AB1, 2, 3 and so on, and we have set the threshold to 520. If the if the LDR is exposed to laser continuously, it will have a high analog value. If you interfere your hand in between, the analog value drops, and when the drop is less than this threshold, a corresponding value is played. For example, if AV1 drops below the threshold, the corresponding note sa from the sargam is played, and so on for AV2, AV3, AV4 and so on. So this is the simple logic of a project, and the further explanations will be given by my friends. Thank you.
Here it is the bill of materials required for the entire system. This is for the lighting system. For a lighting system, we require a microcontroller base which is made up of a foam sheet, cylindrical support which is made up of a cardboard, serial lights and GSM module. This is the bill of material of musical instrument. For a musical instrument, it requires a microcontroller, laser housing which is made up of a foam sheet, Bluetooth module, lasers which are 8 in number, support legs jab 4 in number made up of wood and LDRs. This is the bill of material for the popper. It requires a microcontroller, support legs, and a popper which is made up of a paper rolls or a cardboard cylinder. After this, now let's move towards the functional specifications of the entire system. Our model contains three functions. Those are remote lighting, musical instrument, auto popper. In a remote lighting, when it receives a data by a GSM module, the lighting pattern changes until it receives another set of data from GSM via SMS or through a call. In a musical instrument, it has a 7 notes. If laser is interrupted for a 1 second, the corresponding tune will play. It uses laser and LDR. In a auto popper, when it receives a data via Bluetooth, the popper activates for a 3 seconds and it will pops up.
Now let's move towards modeling and simulation part.
So this is our simulation. As we can see that there are 7 potentiometer values for which a threshold is set. The threshold is set to 500. Now when I give a value greater than 500, here it calculates whether the value given is greater than 500 or not, and the command goes to the switch and the corresponding tune gets played, audio file.
오빤 강남 스타일 강남 스타일 낮에는 따스
Similarly, it works in a similar way for the other potentiometers values also. Now I'll run it.
मेरी नजरों को तुमने सपना दिखाया जगाया मुझे रातों में दबी दबी सांसों में खुशबू ले आया कभी जो न थी राहों में.
It works in a similar way for all these potentiometer values. So now let's move to the lighting and popper part. It works parallelly along with the music part. So when the input is given as 1, that is for lights we are using GSM module. When the input is given as 1, the LED lights glow. This is its working. And when the input is off, and when the input is 0, the LED lights are off. Similarly, the same thing works for popper. The popper is popping out. Your input is given as 1. So that is all about our simulation part. Thank you.
The last step, that is step 5, is the design documentation. All the documentation is carried and documented on GitHub platform. The simulation part is done on MATLAB Simulink 2018A version. We heartily thank you for spending your precious time reviewing our video. This project has helped us come out of our comfort zone, and we have not only learned new concepts but also it has taught us about time management. We thank KLE Technological University for giving us this opportunity, and we will look forward to learn much more in our further semesters. We especially thank our guide Kaushik sir for helping us in our project work and for guiding us in the best way. Thank you.